In this video, we're going to learn how to add and subtract rational expressions. But of course, we need to start with the question, what is a rational expression? And it's just a fraction where both the numerator and the denominator have an algebraic expression, or an expression that has both variables and constants in it. So how do we add and subtract these then? Well, if they have the same denominator, then what we'll do is we'll keep that denominator and we'll either add or subtract the numerators based on what the problem is asking us to do. And then when we have that together, we'll simplify the resulting answer. Let's jump into an example. Let's say I want to add the rational expressions 5 over 3x plus 2 over 3x. You can see that these have the same denominator, 3x. So I can keep that, and I can go ahead and add the numerators. 5 plus 2 will give me 7. So my answer in this case is 7 over 3x, which can't be simplified any further, so that is what I can stop with. Now, what if I gave you the expressions 16 over 5y minus 1 over 5y? Well, in this case, first of all, it's subtraction. And second of all, you can see that the denominators match again. They're both 5y, so I will keep that. But then I'll go ahead and do the subtraction in the numerators. 16 minus 1 is the same as 15. So this gives me 15 over 5y. And that fraction is simplifiable because both the numerator and the denominator are divisible by 5. So I can do 15 divided by 5 and 5y divided by 5 to get 3 over y as my answer in this case. Let's try one more. What if I give you the expressions x over x plus 3 over x plus 3? Well, in this case, still have the same denominator, so I can keep that. And I can go ahead and add the numerators. X plus 3 over x plus 3 is actually super nice because the numerator and the denominator are the same. They cancel and leave me with the number 1. All right, now I know you're asking, but what if the denominators don't match? What if they have unlike denominators? Well, the good news is that the steps are very similar. We're just going to do a couple of additional things at the beginning. So the first thing we'll do is we'll always factor the denominators. Then we'll find the LCD, or the least common denominator. Then we're going to make sure you rewrite each fraction so that it has that LCD. After that, it's the same as what we've been working with. We're going to combine the numerators by either addition or subtraction, whatever the problem asks for, and then we'll simplify the result. Let's take a look at this example. 7 over x squared plus 4x plus 2 over 3x plus 12. Clearly, these do not have the same denominator, so we're going to go ahead and factor the denominators. Looking at our first fraction, x squared plus 4x, we can pull out an x. Looking at our second fraction, 3x plus 12, we can pull out a 3. So what we'll have here is 7 over x times x plus 4 plus 2 over 3 times x plus 4. Now you can see that they both have an x plus 4. But the first one also has an x and the second one also has a 3. So when we're looking for our least common denominator, we're going to list out everything that happens in our fractions at least once. So our LCD is 3x times x plus 4. Now, in order to work with this, we now need to rewrite each of our fractions with that least common denominator. That means we are finding what is missing. So looking at our first fraction, it has x and x plus 4, but it doesn't have a 3. So I'm going to multiply by 3 on the top and the bottom. Remember, whatever you do to one part of the fraction, you always also do to the other. In my second fraction, I have 3 and x plus 4, but I'm missing the x. That's why I multiply by x on top and bottom. That gives me the addition problem, 21 over 3x times x plus 4, plus 2x over 3x times x plus 4. Now I can go ahead and add these fractions, and I get 2x plus 21 over 3x times x plus 4. Notice that I do put the 2x in the front because it is usually a better convention to put the variable before the constant. And that is how you add and subtract rational expressions.